Hey, hello, and welcome to the show. It's me, John Park, and I do not have terrifying infravision, and I'm not lasing things in half currently. Thank you for stopping by. Great to see people over in the chat. The YouTube chat is hopping today. Tackle the World, Dave Odessa, Quinman16, Steve Jablonski, Zoe Sherry, Randall Bone, hello and welcome, and thanks for joining us. Perhaps if you were somewhere else and you're wondering where the chat is, you could step on over into our Discord chat. Look at it right there. That's at adafruit.it/discord. Look for the live broadcast chat channel where you'll see the likes of Yanisku7 and Jim Hendrickson and Mike P, Blitz City DIY, Rufus. Hello, hi, hello all. Good afternoon, and thanks for stopping by. What's going on here? I've got a new product pick for you, and if you want to get a jump start, you can head to that URL or that QR code, and you will be able to watch this video from inside of the product page if you like. It's the future of commerce, maybe. We have at least 100 of today's product picks stashed, and they've been deployed. Oh wow, they are going quick, in fact. So I think we had 100, maybe we only had 50, but I think we had 100, and they are being snapped up because they're half price. So head on over to that URL. You can just throw them in your cart, and so long as you buy them before they sell out or before the show is over, when the price goes back up, you don't need a coupon code or anything like that. You can just simply buy them at a 50% off price. But before I go on any longer about it, let's jump back a little bit in time to Lady Ada's new segment on this hot new item.
Dun, dun, dun. The IR receiver board. So that goes along with the IR demodulator. This board is specifically designed for people who want to do infrared remote projects. You can see, like, you press a button and it's like, I've received this code. So we sell in the store like little breadboard friendly infrared receivers. The problem is that you can't mount them easily, and you have these like little thin legs that you then have to solder wires to. What's great about this is that you can plug in a 2mm JST connector, and then you can plug into a board, and you can see there's like the wiring is very simple. Another thing that's nice is there's a little red signal indicator LED to let you know that it's received signal, and there's two receivers on there you can select between, depending on whether you want horizontal or vertical coverage. So if you go to the overhead, I have a prototype here. It's green, but otherwise it's the same chip. So the first thing is, oh, that's really bright. So let me pop that. 1 moment. Okay. First off, there's two receivers. There's a vertical and a horizontal. And that's because maybe you want to have something that's like edge mounted and you want to have it pointing out, or something flat against the wall, and you want the signal to have as much coverage on the horizontal plane. So between these two, you get, you obviously don't get coverage on the back, although this one does have a little notch, and like this is translucent, so you probably could get some signal even if it was coming from the back. There's a switch to select which one you want to use. You can't connect them together because if they have different signals, they will fight each other. And so you have to select which one you prefer. But on the final version, if you go to this photo, I apologize, I mean this one. On the back, you see that it says IRH, IRV. If you want, you can get the individual signals from each one. If you have two infrared inputs on your microcontroller, as well as the signal, which is the selected output. And then, okay, so can you go to the overhead again? I forgot how to prototype. And then, another nice thing, let's make this less bright, is you can see when you send messages, the signal LED goes off, lets you know it was received. And then I just have a little example code here.
What's the max distance for IR?
I'd say up to 25 meters if you're lucky. It kind of actually depends on the transmitter, not the receiver, right? The receiver will, any signal you get, it'll work. This will probably work about 10 meters away at the most, maybe like, it's best before 10 feet. It's meant to be like a room remote. But we have an IR transmitter dongle that we sell, and it's very high power, and if you use it, you'll definitely get like 100 feet plus, no problem. Okay, so this one, as we press each code is being decoded. and it's like telling you, you do have to, the output is the demodulated signal. It has to go into a microcontroller um, that has an infrared receiver. So in this case, I'm using CircuitPython. Arduino also has IR receiving. Just make sure that you use the right pin and the right library. You have to decode it, like this is an NEC remote. So this board doesn't do any of that, like, oh, I've decoded it to also tell you what the protocol is. It just sends the bit stream out, and then your microcontroller or microcomputer will have to actually convert that into which code and which button was pressed.
Hey, there it is. My things are moving all over the place on the interface here. Whew. Okay, yeah, so that is it right there. I can show you it in the overhead. It's a little dark there, sorry. But that right there is my product pick of the week this week. It is the IR receiver STEMMA Breakout board. This has 2 IR receivers on it. It is tuned for the 38 kilohertz IR standard, which is most of all of your commercial remote controls, like these little multi-purpose ones that we sell. Here's one from a Vizio remote. Here's a Sony TV, little CRT remote. So this plugs into your projects either with header pins or with the very convenient STEMMA QT. No, or with the very convenient STEMMA 3-pin JST connector. It's not the STEMMA QT, it's the 3-pin STEMMA. You can connect this up to your project, and then we have code in CircuitPython and in Arduino that allow you to take this received IR and basically count the pulses and decide what it's looking at, what kind of a signal is coming in. So I've got, first of all, a demo I want to do for you. If you take a look behind me here, you can see I have a PyPortal. And if I take my remote here, I'm actually going to point it at my monitor, and you'll see the little purple IR flashes there. There you can see, bloop, bloop, bloop. This is a non-filtered camera. So let me get myself in there too. Okay, we're all a big happy gang. We're in the picture here. So what's happening is when I press, let's say, the volume up button, you can see my IR receiver back here is receiving that signal, and then it's telling my display to show a different piece of text. So 1, 2, 3, all of these little numbers on here I can press. Let me see if I can do it in a way that you can see. I've got the middle button here. When that gets recognized, that will just say Adafruit on it there. So let me grab this and put that in the down shooter, because I think that'll be a little less cumbersome here. And you can see the actual gizmo in action. So let's jump to, how about that view of the world right there. And I'm going to refocus this. So you can see here is the IR receiver, and it's plugged in with one of these double JST connector STEMMA cables. And then I'll bring my little IR remote in here. If I press up, down, left, right, you can see the little receiver LED blinks there when it receives a signal. It also has the power LED on there. And as we said, there's a top-mounted IR LED. And I'm going to boost the exposure here for a second so you can see things a little better. So right here is a top-mounted IR receiver, I should say. So it's receiving signals. We can flip this little switch and go to the sort of side mount. So that would be for a different orientation of project. So it's kind of convenient. You can pick either one of those. If you want, you can actually receive those two individually using the pinout here. There is a IRH for horizontal and IRV for vertical. Those are the two separate signals. So if you want to use 2 pins, you wouldn't be using the JST connection. If you want to use 2 pins, you can plug that into a breadboard or into PermaProto and be able to receive the 2. They're most likely going to be the same, but you could have an enclosure and a circumstance where you actually have 2 different signals coming in for whatever your use is. So if you want to take a look over here at the code that I've got just to receive these signals and then play the text for the related button on screen. You can see I'm importing Pulse.io and the Adafruit IR remote libraries. Most of the rest of this is just to do with the display. I'll skip over that. But you can see here for the IR receiver setup, we say IR receiver equals Pulse.io, pulse in. I'm picking a digital pin, in this case pin D4 on the Pi portal. The maximum length of the pulse to receive is 120. Idle state is true. And then the decoder equals Adafruit IR remote generic decode. You can do other types of decode that are specific to different standards, such as NEC and Philips and Sony. But this is a generic decode. And then we have a little function here, decode IR signal codes equals decoder decode bits and returns the codes. I have then gone through, and if you take a look at, this is more typical messages you're going to see at first if you just looked in your REPL serial output. If I press buttons on here, I can get the hex code returned of that code that comes in from that remote. And then what I did is each of these buttons we're going to receive a different code. I just made a little table here of the codes I saw and the buttons I had pressed by name so that then I can use those names. So I did that for just this one. This is the Vizio remote, and that's why we get the different names on there, because I know which buttons. Oh yeah, look, that one's Lars TV. You can press that special button right there to watch Lars TV. So this is my little table of codes and strings that I want to display. And then the main loop here, pulses equals decoder read pulses on the IR receiver. And then we get a received code is a variable for decode IR signals based on those pulses that came in. And then I take those, turn them into a string that's called the hex code. That's this type of thing you see here. That's a pretty easy one to look up. And then if that is part of my list of pre-programmed codes, then I change the message to be this little hex code, and then the text area to be that, that message that was up there. If there's not one, if it's a remote, here's this Sony remote that I haven't gone through and written down, now we're getting these much shorter Sony style codes that are showing up here. And then there's a couple exceptions for when we get a signal that was repeated or an error in the decode. We can accept those and print error messages out of there. So that is using some of the sample code you'll find here. If we switch over to here's the main page. Let's see if we've got these in stock still. We have 2 left in stock. If you were thinking of getting them, hit go now. Bye. Here is the Learn Guide that's linked at the bottom of that product page. And you can see here we have a pinout page. It shows this takes either 3 volt or 5 volt, depending on the logic of your board. It can use either. We have a ground pin, and then the signal pin is the output of the board after either one of those 2 receivers, based on the direction that switch is, will send along that signal. That's the one that's on the JST connection. You do also have the separate ones that I mentioned. So if you look here, when we flip the selection switch, we're basically picking between the horizontal or the vertical IR receivers there. And then there's a signal LED and a power LED on the back, and either of those, let me switch to the overhead again, and I'll zoom in a bit, focus in a bit. So if you look here, we have a jumper that you can cut, and that'll turn off the power LED, and another jumper you can cut that'll turn off the signal LED. And those are those 2 on LED and signal LED. If you look on this one that's powered up and plugged in, let me get nice and close to that. You can see the signal LED is actually on all the time, but it gets brighter when it receives a signal. So you can see it sort of blinking there when I press a button on the remote. Boop, boop. So that means it's received a signal. So those are the pinouts on here. The example code and setup we have, both for CircuitPython and Desktop Python using Blinka, are here. And we have some examples using these little mini remotes. These are kind of nice to have just as a generic remote for your project if you're not trying to just decode TV or stereo remote signals from these types. If you just want a project where you can maybe do some preset motor movements or NeoPixel things, you can use this type of little inexpensive $5 remote that we have here. But like I said, you are using a pretty standard, this 38 kilohertz standard for consumer remotes. It would be rare, I think, that you'd find a remote around the house in a closet or a basement or something that wouldn't work with this receiver here. So we have a couple wiring diagrams there if you're not using the JST Breakout or the JST connector, and then set up for Python and CircuitPython. And then we also have an Arduino library and some examples there that you can use. And there are also some more advanced libraries for IR remote that you can play around with. This should work with most any of them. We're just receiving pulses on the board based on the Breakout. Let me see. I'm going to check the Discord for a second here because it looks like there's some discussion going on. Mike P.S., could you use this along with the high-powered IR LED emitter? Yes. So I'll switch back. This is a complementary product here. If you wanted to have two microcontrollers talking to each other from a decent distance wirelessly, you could set up that emitter on one side and the receiver on the other and have them send back and forth. That board that I'm showing there, high-powered, and also has a forward and a up-facing or a horizontal and vertical facing, so you get pretty good coverage. This one sends, I think, on both all the time because it's on the transmitting side. So you get really nice coverage, pretty high power from that. So I've done it from all the way across the house, basically. I've gotten that one to work. So that's a nice choice there. So if you paired the two of those, yeah, you'd be able to do some pretty neat line of sight communication between devices. Also, I will mention, if you take a look over here, it won't be super clear because the camera is focused a bit closer, but you should be able to see that screen changing. When I'm using this, okay, I can point it over there. I can also bounce this right off my monitor. So again, it's fun. This doesn't have the IR filter, so you get to see the little blinky lights there. This one has two for better coverage. And they're probably facing a little away from each other, so we just get a broader coverage. But IR loves to bounce off of stuff. So your average, off-white living room and ceiling, you can point and it'll bounce all over the place. So with this receiver and that transmitter, you can kind of work your way around obstacles a little bit too, just by bouncing things. Comments in the chat. Toddbot claims that be right back, gonna rewire the Wi-Fi to be all IR based. At 38 kilohertz, is that the transmission speed? No, I don't know what your baud rate or your bit rate is of data. I'm assuming video over IR could be a bit excruciating. I will not be broadcasting anytime soon in IR. Let's see, other questions. Quantum Libra says, need a discount on the transmitter too. I didn't think of that. Yeah, we've run that one before. That one we did do on a previous product pick of the week, but we did not have this cool receiver back then. Tsu says, I've been wanting something like this so I can set up a LAN API and hit endpoints to launch IR signals. Oh, neat. Yeah. Once you can harness the IR power, you can do some pretty neat projects where you maybe have Wi-Fi based things like ESP32 microcontroller with these types of receivers on them, so you can send messages via IR from a remote and then get Wi-Fi involved from your microcontroller, or in the other direction, you can send signals over Wi-Fi, have a transmitter side send something. So IR is pretty neat because it does allow you to bridge a certain type of use case. You've also got a IR transmitter on the Circuit Playground Express. So if you have one of those, that does have an IR transmitter. So does the Circuit Playground, the original one. That's a case where you may already have a microcontroller that can transmit, and if you get this little receiver here, you could have a second device actually receiving. All right. I think, yeah, Jeff Hunt's question too, can this handle sending streaming data between microcontrollers? Indeed, yeah. So if you have a transmitter on one side, receiver on the other, you could put both on each. So if you wanted to do two-way stuff, you could do that too. All right, good. What have I missed? Yeah, so here's the Learn Guide, as I mentioned. In the downloads section, we have some more product demo example code, schematic diagram there that you can download, a little board, fab print there. There's a fritzing object available too, so if you want to put together a nice visual of your project, you can go and get that. Oh yeah, Sue mentions in the Discord these candles. Oh, sorry, I was blocking that. Yeah, so there's the downloads link of the Learn Guide. But I love this. I have some of these. I have some of these wax candles that have little flickery flame LEDs in them. They're great. They even move a little bit, physically move. It's not like just a flicker effect, but I think these are on like a little tiny pivot and they wiggle around. And they use a remote very similar to this to control them. So if you take something like this and grab whatever weird remotes you have around the house, point them at that, you can get that code, use that in transmitter projects. So it's a nice way to just go around and look at things. You could probably also do stuff like figure out the protocols. So a lot of TV remotes will have their own house brand, like Sony has a few of their own IR protocols. I think Panasonic has some of theirs that are the same as Toshiba, but some people use NEC standards, and so you could probably set this up so that it would just tell you what standard it's using, not what the button is, but just based on the little header bits and things, what standard it's receiving. So there's a lot of advanced stuff you can do once you can look at those codes kind of easily. All right, yes, and we are out of stock of them, so I hope if you were interested and wanted to get them at the discount price, you got some. If not, they are not actually prohibitively expensive. I think they're normally $5. So if you're interested in getting these anyway, I say go for it and do some cool projects with them. Show us what you have made with your IR stuff. So I think that's going to wrap it up. Anything else? Here's some nice close-up product photos we have of them. You can see the little two receivers there, horizontal and vertical, and the little switch there for flipping between the two. There's the backside with the little jumpers that you can cut. Right. Let's wrap this up then. Okay, so that right there, that's my product pick of the week this week. It is the IR receiver STEMMA Breakout board. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. I'll see you next time. Bye-bye. Lays.